Hello out there everyone, and welcome to this video today. In today's video we shall be looking at an alternative answer that you can give that you can present as a solution for the integral of sec x dx, and it is also going to be a very easy method, guys, if you know your trigonometry so well. If you don't know trigonometry, just check out my video. I have a video on trigonometry, but guys, you can always see it if you're subscribed, if you have subscribed to the channel, because it is visible mostly to subscribers. Okay, now guys, let's dive straight into it. But guys, please don't forget to subscribe to the channel and like the video, because that is going to motivate me to produce great content for you. Thank you very much. Let's get started. Okay guys, this is it I have. All right, now guys, to integrate integrate sec x, we should recall that sec x is given as what? 1 over cosine of x, right? So we have the integral of sec x, which is the same like the integral of 1 over cos x dx. Good. So guys, we are going to write this cos x as cosine of 2 times x over 2. Great. And you see the beauty of doing that, because you can put this one as the integral of 1 over cosine of 2 into x over 2, like I said, because this 2 and this 2 can cancel, and you still have the integral of cos of 1 over cos x back as you had initially. So guys, in this case now, we are going to let a substitution. We are going to let our t to be the same like tan x over 2. We'll let t to be tan x over 2, guys. That therefore means that if we take the original tan inverse on both sides, if we take arctangent or tan inverse on both sides, we are going to have tan inverse of t equal to x over 2. Great. So now if we differentiate this guy, now if we differentiate tan inverse of x over t, we are simply going to have 1 over 1 plus t squared dt, right? Yeah, great. So guys, I'm simply stating this the derivative of this guy because I have a previous video on it. So please, if you've not watched that video on why we can live from tan inverse of t and we arrive at 1 over 1 plus t squared after differentiating, please just check out my other video. Just check it out. I'll put a link to that video in the description below. So guys, please check it out so that you're going to be clear. Good. Okay, now guys, we differentiate tan inverse of t, like I said, we are going to have 1 over 1 plus t squared dt, means we are differentiating with respect to t. Great. And we differentiate x over 2 with respect to x. We are simply going to bring out the 1/2, then we multiply by dx. Great. So we are simply going to have 1/2 dx. Great. So guys, now if we make dx the subject by multiplying all through by 2, the 2 will cancel here, then we have the 2 this way. We have dx to be the same like 2 over 1 plus t squared dt. Great. So now guys, let's keep in mind that cos 2 into x over 2 is the same like 2 cos squared x minus 1. Yeah, 2 cos squared x minus 1. And guys, I also have a video on this guy. I have a video on this. I have a video where I prove the trig identities and their half angles identities. So guys, please just check it out. Okay, check it out. That one is mostly for subscribers. It has made visible only for subscribers. So guys, just hurriedly hit the subscribe button and like the video so that you are going to have access to great contents that have been hidden from you. Thank you very much. All right. Now, like I said, keep in mind that this cosine of 2 into x over 2 is the same like 2 cos squared x into x over 2 minus 1. Great. So guys, we should also know that t from this from where we started, right? T is equal to a tangent of x over 2. That therefore implies our tangent of x over 2, guys, is the same like what? T over 1, right? Because this t is the same like t over 1. So just simply take note. So guys, in this case now, we can therefore draw a right triangle of this form. We can have a right triangle of this form where we know that our tangent, please keep in mind that the angle is here. This is where we are going to have the angle. Just that I didn't indicate it. This is going to be where we are going to have the angle. Okay, this is where the angle is. This is where the angle is, guys. I'm sorry I didn't indicate it, but this is where we're going to have the angle. That therefore means that tangent is given as opposite over adjacent, right? Our opposite in this case is t, adjacent is 1. So we are simply going to have have our opposite being equal to t, then the adjacent, which is our adjacent in this case is what now, guys? It is 1. Great. Then now to figure out what we are going to have as the hypotenuse, we are simply going to take the square root of t squared plus 1. Okay, we simply take the square root of t squared plus 1. That's from Pythagoras theorem. So we are simply going to have the square root of t squared plus 1, and by so doing we are going to have as what we have here, the square root of t squared plus 1. Okay, now guys, having this right angle triangle of this form, of which the angle is at this point, this is where the angle is. Guys, like I said, I'm so sorry I didn't indicate it. I'm so sorry. This is where we're going to have the angle, the x/2 angle. Good, this is where we're going to have it. So now guys, having this in mind, now we can therefore come out by saying that that cosine of 2x/2 is the same like what? From what we have here is the same like 2 cos squared x/2. What is cos squared x/2? Cos squared x/2, according to this according to our right triangle, is simply going to what? Adjacent over hypotenuse. That is from SOHCAHTOA, right? From SOHCAHTOA, we have the cosine to be adjacent over hypotenuse. So the adjacent is 1, and the hypotenuse is what? The square root of t squared plus 1. Oops, guys, this is supposed to be t. Okay, I'm sorry, this is supposed to be t. This was supposed to be t, not x. It's supposed to be t, not x. Good. So we are simply going to have this. Now guys, we are now going to have now the integral of 1 over cosine of x dx to be the same like the integral of 1 over cosine of 2 into x/2, but cosine of 2 into x/2 is the same like what? 2 into 1 over square root of x of t squared plus 1, all that squared. Notice that this square is going to cancel the square root, right? So we are simply just going to have 2 over t squared plus 1. Then we have this minus 1 this way. This is the minus 1. Then now, what is our dx, guys? What is our dx? According to this step, we saw that our dx was what? Was 2 over 1 plus t squared dt. That's why I have it here as 2 over 1 plus over t squared plus 1 dt, as I have here. So now guys, if I multiply all through, if I multiply top and bottom by 1, if I multiply top and bottom by t squared plus 1, I am simply just going to have the integral of multiply here by t squared plus 1 is going to cancel with this guy. So we have our 2 here. Then multiply -1 by t squared plus 1, we simply have -1 into t squared plus 1. Then multiply up here is going to cancel with this one down, and you simply have 2. Great. So now guys, if you simplify further, you are simply just going to have the integral of 2 over 1 plus over 1 minus t squared dt. Good. So now guys, you see that the bottom is like the difference of 2 squares, right? So we can express this guy as the difference of 2 squares. Then we express in partial fractions of further. So we are simply going to have that the integral of this guy now is the same like the integral of a over 1 minus t. This has been expressed as the difference of 2 squares already. Then plus b over 1 plus t dt. So now guys, I'm not going to do the partial fraction. I'm not going to simplify everything to ground level for you, but you are going to use the cover-up method, guys. You are going to use one of the famous methods that work for all partial fractions, so long as the denominator is linear, are all linear. It's called the cover-up method. Just leave it in the comment section if you want me to produce a video on the cover-up method, because with the cover-up method you get the values of a and b in less than 5 seconds. Yeah, you heard me right, guys. You heard me very, very loud and correct. You get it in less than 5 seconds. You get the values of a and b. So guys, we integrate this guy now. If we use the cover-up method, we are simply going to have our a to be 1, our b to be 1. Good. So now if we now proceed with the integrations now, guys, we are simply going to have the integral of 1 over 1 minus t is going to be what? The natural log of the absolute value of 1 minus t. But guys, keep in mind that the reverse chain rule says that we divide by the derivative of the inside. The derivative of 1 minus t is negative 1, so that's why we have the negative outside here. Then the integral of this guy simply gives us natural log of the absolute value of 1 plus t. Then chain rule says that we divide by the derivative of 1 plus t, which is going to give us 1. That's why here is just empty. Good. Now guys, you know that this is integrations, right? Once we are done with integrations, now we can never simplify. Great. So now simplifying that, we are now going to have the natural log of the absolute value of 1 plus t over 1 minus t, because we are going to apply the in this case we are simply going to apply the one of our laws of logarithms, right? Yeah, since the negative sign is this way, now we are going to have the natural log of this guy, now all that about the natural log of this guy. So we have this plus c. Oops guys, the plus c was supposed to be at this level, but don't bother, I'm going to put it right now. Good. That's why we have the plus c. As soon as you're done integrating, you simply put your plus c. That's it. So guys, this is the answer for our integral, but we are integrating Secx, not something that has to do with t. So we simply replace everything. We simply replace our t by what was our t? It was tangent of x over 2, right? So we are going to replace everything now to have the natural log of the absolute value of, we have 1 plus t, which is tan x over 2 into 1 other than 1 minus tangent of x over 2 plus c. So guys, this is the answer for our integral. So guys, the integral of Secx can also be stated as the natural log of the absolute value of 1 minus tangent of x over 2 over 1 over, it can be stated as the natural log of absolute value of 1 plus tangent of x over 2 all in 1 minus tangent of x over 2 plus c. So guys, this answer with the one I gave initially, if you differentiate them, you are going to see that they will be the same, but they might be off by constants. Okay, the constant of this guy might not be the same like the constant of the other part of the integral. Yeah, so thank you guys for watching the video, and I hope to see you in the next video coming up very soon for subscribers. Thank you very much, and don't forget to subscribe to the channel and like the video, because that does motivate me to produce more great content. Thank you very much indeed, and have a great day.